If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture of this gate electrical circuit series. So today we will be solving from question number 91 onwards up to 95. 5 questions we will be solving. Okay, then let's try to solve these questions. Now if you see 91, the voltage and current waveforms for the elements are given in the figure. The circuit element is, if you see here, your current is changing. As your current is changing, you are getting voltage. When current is fixed, then voltage is zero. So which circuit give like this? So you can see your voltage is the differentiation of this one. What is the differentiation of this line? Because it is a straight line, differentiation of straight line, inclined straight line is a flat straight line. You know this one because differentiation will give me slope, because it is constantly increasing, so the slope is fixed. Now differentiation of a straight line is 0 because the slope is 0, so differentiation will be 0. So it is nothing but the differentiation of this one. So who gives you differentiation of this one? V is my differentiation of I. So who gives you this one? By this you can already see it is V L di dt. So circuit element is L, obviously inductance, and what will be the value? You see the way here V is 2 during this period, and it is L I don't know, and this di dt is the change. So 2 by 2, it is all ampere in second, so 2 by 2, so that means L is equal to 2 Henry. If you see 92, in the circuit shown in the figure, it is desired to have a constant direct current IT through the inductor L. The nature of the voltage source must be, so current should be constant. So here what is the formula for V? V is equal to L di dt. Okay, now this current is constant, they are saying. So if this is constant, that means your VL should be 0. So 0 means if you give no voltage, then how come it will come? So obviously it will not like this. So you can think it also in this way. Your IL is nothing but L. So it will be 1 by L integration of VL dt. You can think this way. And IL is constant doesn't mean it is a constant of. You can think it also as unit step, because unit step UT. This is the value of unit step. How does unit step defined? Unit step is 0 if t is less than 0, it is 1 if t is greater than 1, and at t equal to 0 it is undefined. You remember this one, at t equal to 0 it is undefined, it is not at t equal to 0 1. After 0 plus it is 1, just after at 0 you don't know what is the value, at 0 minus. So this is the condition of unit. You can think of this also unit step. Okay, now you have this IL, you can thinking of a unit step. So what is the differentiation of unit step? What is the differentiation? Because this differentiation is your VT, or you can say reverse also. What is the integration of V so that it I? So what is the, you no need to write also, you can think this way also. What is the differentiation of this? You have heard about this one, unit impulse. We will all revisit this one once again. In signals and system, where we will start this one. So this is my delta t, which is known, and 1 is also written. What is this 1 means? What is the mathematical expression of this? Is also known as delta function. Unit impulse, or some book you will find also it is known as delta function. What is this? At t less than 0, it is 0 at t less than 0. It is 0 at t greater than 0. At t equal to 0, it is undefined. That is infinite. You don't know what is. So it is a very high pulse at a very short duration. So what does this unit impulse suggest? What is the meaning of unit impulse? If I am explaining it, let us explain it in clear detail. From what is this unit? What is this 1 means? This means nothing but it is assumed to be mathematical expression that is the infinite pulse, but for a very small duration. The duration is so small that if you take area under this, you can think of this small segment. If I am zoom it, suppose I have zoomed it, this impulse, so it is a small rectangular type shape, and the area of this one under this curve is 1. That is unit impulse. That's what is known as. That means from 0 minus to 0 plus, if you integrate delta, it will give you 1. So that is the meaning of 1. 1 means it is the strength of that signal, that is known as unit impulse. If it is written 8 delta t, means 8 times that unit impulse they are giving. So unit impulse means the area under that unit impulse total. If you take from here to here, everywhere it is 0. So you will find between only this portion, only 0 minus to 0. If you integrate this one, you will get 1 unit. That is the strength of the delta t. So this is known as unit. So now you can easily think what is the differentiation of unit step, because constant you don't think simple constant, because simple constant will give you 0 answer, which is not possible here, because if you give 0 voltage, no current will flow. You can think constant means it is a unit step. After switch giving, it is a constant flat in terms of signal. So the differentiation of unit step, it is the differentiation of this one. You differentiate this one, you will get this answer. T minus 0 0, t greater than 0 0, at t equal to 0, it is undefined, because the original function is undefined, differentiation is also undefined. Don't worry, you will again revisit this all these signals in signals system, and we will try to learn it in depth in that case in signals and system. Then it will be everything clear. But these basic things you should always remember. Now, when a periodic triangular voltage of peak amplitude 1 frequency is applied to the parallel combination of 1 ohm and this much. Okay, there is a parallel combination of resistance and a capacitance. Resistance is one here, and the capacitance is this one. So you connect a periodic voltage source. It is periodic triangular. It is not alternating triangular. You can be careful. It is periodic triangular. This is periodic. Don't go negative side. Negative is alternating triangular. That means magnitude is changing. It is just period. So it repeating after period. So this is your V. So what is your I? Total I is equal to this current plus this current. So if I draw these two current, then I add these two, then I will get the graph of total current. So V and I, because it is resistance, it will be same. It will look same, because for resistance there is no change. The way V varies, magnitude can change depending upon R values, but the shape will, because we are interested in shape only. This is this one. And what is C? It is C, parallel combination of capacitance C. So what is C? IC. This is IR. What is IC? C dVdt. Now you have already seen, if it is an inclined line and if it is a positive inclined, then the slope is positive, because the slope is positive. So IC is nothing but the slope. Slope is positive, and here slope is negative, so IC will be negative. And here again IC will be positive. Here again IC will be negative, because this is slope. IC is nothing but the slope of the V. So this will be the curve. Now if you add these two, what will be the curve? If you add here, you can think here, because it is flat, then you are adding. This is constant 5, then you are adding. So from some constant value it will keep on rising. It will reach there, and once it reaches there, then it is negative, then it is 0. So it can go up to 0, and after beyond that point, this is negative and this is something positive, but it is decreasing. So negative value will get increased gradually, because it is minus 10. So first it is 5, so minus 10 plus 5, 5, then minus 10 plus 3, minus 7, then minus 10 minus 1, it will be minus 9. So gradually it will increase, up to this value it will increase, and then again it will come down here, and again, because this is also positive, so it will again increase, it will come here, and then again it will. By now you have already got to understand what will be the nature of this one. So you can see which curve is giving me this nature. You can see it should be increasing, and then something of this fashion D. 94 rectangular voltage parts of magnitude this and direction T is applied a series combination of RC. What is this? A rectangular voltage pulse. This type of voltage pulse is given up to T. A rectangular voltage pulse of magnitude V, duration T. The duration is T up to this much only, and this. Up to this only they have applied, and the series combination of RC, maximum voltage. So if I apply, what will be the voltage? Let me think that it is V is constant, it is flat. Let me don't think that is up to T is applied. So what is the expression of VCT? What is the final voltage? If I apply it continuously, then it is V. Initial is my 0, final is V to the power minus T by RC. This is the formula that we have seen. Now can you draw this plot? So this is the way it should follow. The capacitor should charge in this form. For this, let me draw something. E to the power x curve. How is e to the power x? This is e to the power x. If you put 0, 1, if you put minus infinity, then it is 0. If you put infinity, it is infinity. If you put minus 1 x, then it is this way. 0, it is 1. If you put minus infinity, then it is minus plus infinity, answer will be very high. If you put plus infinity, then e to the power minus infinity, answer will be 0. If you put minus of minus e to the power x, then how it will be? It will be of this, just of this fashion, because if you put, the answer will be negative here. Here it is positive. If you put 0, answer is minus 1. So this is. Now if you add this one, this is nothing but if you add 1 plus minus e to the power x. 1 plus minus. Now how the graph will be? Because 1 is there, flat 1. Along with 1 you are adding this one. So initially it is 0, because it is at minus 1 at 0. So it will be from 0. Then it will step up by 1. So ultimately it will reach to 1, because it will reach 0. So here it will reach 0 plus 1, 1. So this is the shape of this curve, 1 minus e to the power T by RC. That's why you always remember this shape is this one. You have already seen an RC circuit. Now mathematically also you can see how these graphs are coming. So you should be very clear how e to the power x, e to the power minus x, these graphs are coming. So this capacitor will get charged up to voltage V through this in this way. but do you know it will go up to V? I'm not sure, because it is given up to t time. So up to t time, whatever value is reached, I don't know what value it reach. So up to t time it will reach here, suppose. So if I put t, because after t there is no voltage, again it will start decreasing. So decreasing will be in this way. So decreasing will be in this way, because it will be just minus. If you do, it will be V. How capacitor discharge? Discharge is because final value in that case 0. Initial will be the value where you have left it. Suppose you have left it V dash, so final will be 0 here. It will be V dash. It will be 0. So V dash e to the power minus t by RC. So it will be this curve. V dash e to the power minus something. So it will be this curve. So it will follow this one. So this capacitor will charge up to this, and then it will decrease up to this. So what is the value? T. So here it will follow this curve, and here it will follow V dash e to the power minus t by RC. The expression is this one, sorry, not t, t minus t, because it will start from, t means it starts from 0, because it is starting from discharging from point t, so it is t minus t. Again I am writing, what is the graph of this one? V dash e to the power minus t minus capital T by RC. This is the graph of this curve, and this is the graph of this one. You can understand this one, because it is charging. So initially it was 0, these two are final. Same expression here. If how it is coming, final is 0 because it will discharge to 0. Initially it is discharging from V dash because you charged it up to V dash. Final is 0 e to the power minus t by RC, minus t minus capital T, because it will start from capital T. So that's what. So what is the peak value? Peak value is here. So at t. So at t, what is the output? It will be V into 1 minus e to the power minus. Instead of t, you will put capital T. So this is the maximum value it can attain. This is the max. So that is your option A. So this graph you have to be careful about, so that you can, in a twist and turn is there, you can easily go through it. 95, what they have given, the voltage waveform V is applied across a 1 Henry inductor with this initial current through it being 0. Initial current 0, this means it is okay, there is no, you are applying a voltage source through an inductor. Initially it is 0, and this is Vt. So your I will be equal to L di dt, because there is no current. Otherwise, if there is a current, we should have to put that current in parallel with that inductance. Because there is no current, no issue. So it is L is what? L is 1 Henry. V is equal, I is equal, VL is equal to L di dt. So which one is required? V is given. So IL is equal to integration of 1 by L VL dt, and we will integrate from 0 to t. So through inductor is given with the initial current through inductor, just t in terms of t. So it is 1. It is integration of VL is 12 t square 0 to t dt. So you can find it 12 t cube by 3, and 0 to 2 it will be t only, so it is 4t. So that is your option D. If there has been one more current source, then you have to put that current source, and that inductor current will be this plus this. L di dt plus that initial current will also come, because there is no initial current, that's why this extra initial current I am not putting. So it is only 4t cube. So okay, that's all for today. If you like the video, then press the like button, and please give your valuable comments in the comment section.